This is question 16 for section 6.3, the chapter on probability using counting techniques, or it's labeled like Introduction to Probability, but that's really what this is. All right. So this question reads, we're selecting a committee by randomly picking people from 8 nurses and 2 doctors. We need the minimum committee size that ensures at least a 90% probability that it will not be comprised of nurses only. Okay, so first things first, we're going to define our event, and I'm going to make it N, and I'm going to say that N means we have nurses. Wow, it's not how you spell nurses. Nurses only on the committee. The reason why I'm defining it this way is because I see that not there, it tips me off that I'm going to need to use like this formula here. We're going to think about like finding the chances of the committee being composed entirely of nurses and just take one away from that. And we need this to be greater than like 90%. So we're going to be working with this like formula here. Here we go, and we're going to be working with N greater than 0.9. Well, also this has to go away, and this has to be N right there. Okay, cool. So we have this. Let's see. We also need another variable, which I will define as soon as I can move this right here. We need this variable, and we need to say let X be the committee size. So in other words, X is the number of people we are picking. Okay, so we're going to look now at the probability of N. And again, we're going to be using that formula that we like know and love so much. Number of outcomes of event A divided by the total number of outcomes. We're going to be looking at this formula as usual. Okay, so let's look at the total number of outcomes first. That's a little bit easier to calculate. If X is the number of people that we're picking, and there's 10 people to pick from, because we have 8 nurses, 2 doctors, there's 10 people to pick from, then I should say choose. It's 10 choose 2, or sorry, not 2, X. 10 choose X. That's going to be our denominator, our total number of outcomes. Because again, if you're on the committee, you're on the committee. Doesn't matter if you get there first, or like if you're picked first, or third, or like last. If you're on the committee, you're on the committee. So we're using combinations. Order doesn't matter. And this is going to be our denominator. Remember, we're calculating the probability of N. So I guess I should write that. This is our like probability of N. So that'll be our denominator. This like 10 choose X. And then because we're looking for the like, what if only nurses are on the committee? The people that we choose X from, they need to be nurses. And there are 8 nurses. So we're going to have something like this in the numerator. We're going to have to clean up this fraction a little bit. So I'm going to do that over here. We're going to clean up this fraction a little bit. I'm going to expand out the like combination formula. So in the numerator, I'm going to have 8 factorial. This will be x factorial, and then 8 minus x factorial. That's the numerator. In the denominator, I'm going to have 10 factorial, and then x factorial 10 minus x factorial. So there's a few ways to like treat these. We can multiply the top and the bottom by x factorial 8 minus x factorial, and then we can also multiply the top and the bottom by 10 factorial. Like 1 over 10 factorial. This is an option. You don't have to do it, but like this is one way of doing it. We can look at these two fractions. So like this fraction here and this fraction here. We can look at them as division of fractions, because that's what it is. We have a fraction in the numerator, fraction in the denominator, and this like giant fraction line between them. So it's a division of fractions. And we know how to divide fractions. We can change it to multiplication by grabbing this and just taking like the reciprocal of the, wow, what is going on? I said taking the reciprocal of the like second fraction, the divisor, and then changing that divide into a multiply. We could do that. Come on. Okay. Sorry about that. Changing that divide to a multiply and then going from here. Either way you choose to simplify your fraction. I'm not going to go in depth on how you do that because I expect you to know how to do that. But either way you do it, you're going to get 10 minus x factorial in the numerator and 90 like 8 minus x in the denominator. This 90, this could be like 9 times 10, maybe you might have that, but it's going to be something like that. It's going to look like this or equivalent. It's not really like the, I guess, main point. But because we just need to take this and put it into our equation over here. So I'm going to get rid of that. We're going to grab this, that there. We're going to grab this. We're just going to put them on the same line. Okay. So 1 minus p of n is going to be the same as like this thing, what we have over here. Now, what do? This difference needs to be greater than 0.9. There's a few ways of tackling this. Number one, because we need x, and we know that x has to be a whole number, because we are like picking people to be on the committee. If you're picking people, you can't pick half a person or 3.72 of a person. So x can be 0, 1, 2, 3, all the way to 8. 8 is the greatest value because after 8, 9 is the greatest value. Because let's say you're picking 9 people to be on the committee. You only have 8 nurses and 2 doctors. So if you pick 9, then you're guaranteed to have 1 person who's not a nurse be on the committee. So like our x can range from 0 to 9. And the way that you find x, it's actually not as fancy as you think. You try different values between 0 and 9 until you get one that makes this difference greater than 0.9. And no, that is not a joke. At this level, there is really no way to solve an equation where the x is like a factorial in the factorial, right? Where the x is like either a factorial or in the factorial. You just try different values of x. The way to do this efficiently is to bring up Excel and write an equation in Excel for this like scenario. I've already done that. So that's our equation in Excel, and then we just look at the number that makes this probability greater than 0.9. In this case, that is 7. Yeah, in this case that is 7. If you were to do this without Excel, you would literally be like sitting there with your calculator trying different values of x until you found one that gave you like a number that's greater than 0.9. After you found one, let's say it's 8, you're going to try like 7 and see if that works. And then like after you try 7, you're going to try 6, see if that works. And if 6 doesn't work, then you know, oh, it's probably 7. Yeah, that's basically how you do it. Like, at this point, you just try values of x. And yeah, this seems really simple, but trust me, this is an actual math technique. Trial and error is a math technique. And it is a tool that you can use. Usually we don't use it. In this case, we kind of have to. Try values of x, and you will find that x has to equal 7. So we need to pick at least 7 people. That's the minimum community size to ensure at least a 90% probability that it will not be comprised of nurses only.